All right, functions. Hi, missed you already, but today what I need you to do is, this is the warm-up. You are going to get about 10 minutes to complete this. Make sure you get your triangles correct, and the sub is going to hit pause now. Okay, so I drew all my triangles, and I want to make sure that we get this, because on the test we got a lot of us got some of these wrong. We either got the angles mixed up or we got our side lengths mixed up. So the big thing with a 30, 60, 90 degree triangle, the big thing that we need to remember is that our hypotenuse is always going to be 2, because it's that equilateral that we cut in half. So notice here that my hypotenuse is 2 here, but in this one it's like the other half of that triangle, and my hypotenuse over here is 2. Then that makes that one of the legs is going to be the square root of 3, and it's always going to be the opposite of 60, which means the opposite of 30 degrees is always going to be 1, and that's true here. And then with our 45, 45, 90 degree triangle, we need to be really careful because we have a side length of 1 with the square root of 2. So if I'm finding the tangent of 60, then the tangent of 60 is my opposite. So my angle's right here. So my opposite, which is the square root of 3, over my adjacent, which is 1, which is just the square root of 3. Then we have our secant, which is the hypotenuse, which is the square root of 2, over 1, which is just the square root of 2. And then we have my cosecant, which is the hypotenuse, which is 2, over my opposite side of 30 degrees, which is 1. So everyone should have gotten that, and we're going to go ahead and go to the next slide. All right, so when I look at this, we are now talking about using a triangle on the coordinate plane. So we have seen, and you don't have to worry about this, but we've always used, to find the hypotenuse, we've always done a squared plus b squared equals c squared. So then this would be my a, this would be my b, and this would be my c. So if we did that, if I were to solve for c, I would take the square root of c, and then I'd have to do that on this side, because what I do on one side of an equation, I have to do to the other. So then I end up with the square root of a squared plus b squared, hold on, my root should be all the way over it, is equal to c. So that's where this comes from. So now we're going to be talking about x squared plus y squared equals r squared. That's what we're going to talk about because we're on a coordinate plane. So if I were to draw, let's say I give you the point 2, 3, I were to draw that triangle, I would just go like this. So there's my coordinate plane. My x is 2, so I'm going to go 1, 2, and my y is 3, 1, 2, 3. So my point is going to be right here. Then I'm always going to draw my hypotenuse line from the origin. It always starts at 0, 0. I'm going to go, oh man, I did not go through that point. Let's see if I can. Let's see, go through the point. There we go. And then I'm going to draw in perpendicular. So then I know the length of this is 2, and the length of this is 3. So then I'm going to find my missing length, which was the line that I was drawing through. And actually, I need to finish drawing it. Here, let me see if I can fix this. I'm going to hit pause and try to erase my mess. Okay, so I kind of fixed it. So now I need to find my r, which is right here. So what I'm going to do is I'm going to do 2 squared plus 3 squared is going to equal r squared. Well, 2 squared is 4, and 3 squared is 9, and that equals 15. And then I have to take the square root of that, and I end up with, you have to do the square root of both sides, right? So then I end up with the square root of 15, which is, that is it, just the square root of 15. So go ahead and hit pause. And let me know when you are ready to move on, or let yourself know when you're ready to move on. And yeah. Okay, so now's a good time. We are going to move on. So now we're going to take that same triangle and we're going to add trig functions to that. So if I were to use the same triangle we just came up with, and I want to use x, y, and r instead of a, b, and c, or opposite over hypotenuse, then we are going to be talking about how sine is my y value over my r value. So whatever my y is, it's going to be over my r. My cosine is going to be x over r. My tangent is going to be y over x. My cotangent is going to be the reciprocal of my tangent. My secant is going to be my reciprocal of my cosine, and my cosecant will be the reciprocal of the sine. So go ahead and hit pause now, because you're going to want to get this in your notes, because we're going to do a couple of examples. Okay, so now let's go through this. If there were any questions, I would like you to write them down in your notes. That way I can get those questions from you when I come back. Or if Mr. Temple's in there, please ask him. That would be very helpful. Okay, so now we have that the sine of theta is y over r, the cosine, we have all of that, our unknown angles. So now, oops, come on, there we go. Okay, so now we're going to do this one. So right now I'd like you to hit pause. I would like everyone to please find the missing side length of this triangle. So hopefully everyone found that and you used it by doing x squared plus y squared equals r squared. And then we can plug in our x and our y values. So that's 8 squared plus 15 squared is going to equal r squared. So we think it's 64 plus 225 square root of, and then we have to take the square root of both sides. So we have 289. So then we end up with 17. So now we're going to do the 6 trigonometric functions for that triangle that we just found. So in your notes, I'd like you to finish. I gave you sine. So sine is going to be 15 over 17 because it is this side. And we said it was y over r. So go ahead and find the other 6 trig functions. So hit pause. Okay, so then we have our cosecant is going to be the reciprocal of that. Our cosine is going to be 8 over 17. Our secant is 17 over 8. And then 15 over 8 and 8 over 15. So hopefully you got all of that. All right, so now I have an example of starting from scratch where the triangle isn't given. So we are going to draw this triangle. If we are looking, we have to point, okay, we know that we have a terminal side of an angle, theta, is in the standard position, passes through. So let's see. We have negative 1, 2, 3, up 1, 2, 3, 4. So there's my point. I'm going to draw my ray through, starting from the origin. Ooh, I think that might be my best one. I'm going to drop this down. I know that this is going to be a length of 4. I'm going to drop this, and it's going to be a negative 3 over there because we went to the left of the 0, and it's on the coordinate plane. So then I need to find my r. So go ahead in your notes, find your r, and I'm going to do negative 3 squared plus, and I'm going to go ahead and put parentheses around that so I remember if I'm going to use my calculator, which I shouldn't need to, but if I needed to, I would have that. 4 squared is going to equal my r squared. So negative 3 is negative 3 times negative 3 is a positive 9, plus 4 squared, which is 16, is equal to r squared, and so then I get 25 is equal to r squared. I take the square root of both sides, and I get 5. So my triangle right there should be 5. So now I want to find the sine of theta. I want to find all 6 trigonometric functions. So I'm writing them all down. And then we have cosecant of theta, secant theta, and then we have cotangent of theta. All right, so go ahead and hit pause. I would like everyone to do that part in your notes on your own. Okay, so we said that sine was y over r. Well, my y value is 4. My r value is 5. We said that this is going to be the reciprocal, so we have 5 over 4. Cosine we said is x, so we have negative 3 over 5. And then tangent is x over y. I'm sorry, y over x, so we have 4 over negative 3. But remember, we don't want a negative in the denominator, so I'm just going to, and a positive divided by a negative is a negative, so I'm just going to do negative 4 over 3. And then we have our reciprocals over here, so we have 5 over Again, we have that negative, so I'm going to throw it right there. And then we have negative 3 over 4. All right, so that was my last example for you today. You should have just enough time to finish. There's 2 questions on my math lab, 1 and 2, that you should be able to do. If you have any questions, let me know. Otherwise, I hope you all have a great weekend. I hope that you stay safe, stay healthy, stay legal. Don't do anything illegal. But anyway, bye everyone. I hope you have a great weekend. But do work on my math lab. This test for you will be on Tuesday after Memorial Day weekend. So it'll be after a long weekend, and it'll be your last test with me. So I will see you all then. But we'll work together until then.